Hello, everybody. Thanks for coming to my session. What we're going to talk about today is Spring Cloud Function, write once, execute anywhere, why is that, and so on. So I will hope to cover all of these topics. I do have plenty of time, but we'll see how it goes. So about myself, my name is Oleg Zhurakousky. I am a long-time Spring user, employee, and so on and so forth. Currently, I lead the technical lead for Spring Cloud Function and Spring Cloud Stream projects. A quick show of hands, how many here are Spring users in general? Very good. So, yeah, we're going to talk about Spring, but Spring, if you remember Spring, early 2000 versus Spring today, they're completely two different things because we try to solve different problems, try to solve them differently, kind of adjusting to the current landscape of technology that is available to us. So yesterday, I sat with my colleagues at the dinner, my Polish colleagues, Marcin and Olga, you may know them. And we had an interesting discussion about sort of the style of presentation, how we want to address a particular topic, because a lot of times it seems to us that we are sort of talking about things that may seem to be too obvious. And a lot of times it is, because at the end of the day, we all Java coders, we sort of do similar things day in, day out, right? So, but one thing we found interesting is that instead of talking about what you can do with something, how about we'll reverse it and say, listen, let's start with the problem. What kind of problem we're trying to solve? So then, when it comes to what can we do with a particular framework or technology, it resembles more as to how this technology helps you solve a particular problem. So the problem of today is events, right? So I'm going to read from the slide kind of a quote from Wikipedia. So event-driven architecture is a software architecture paradigm promoting the production, detection, consumption of, and reaction to events, right? So I stole it from Wikipedia somewhere. So events usually signify the change of state, which we want to record and or react to. Events, they don't move by themselves. They occur, right? So there's other frameworks, other technologies that help us to move the events, help us to recognize that event has happened, right? So it often relies on various different network-based systems to communicate those events so we can act on them. Representation. How do we represent the events? About a month and a half ago, I was in Barcelona for a Spring I/O conference, and there was a speaker who was presenting this session on microservices, serverless, and everything else. And there was a phrase that I didn't quite agree, and I want to sort of elaborate on that. So she separated message-driven architecture versus event-driven architecture. And to me, that doesn't seem to be very accurate, because it's like comparing apples and oranges, right? So what is event, right? If something happened, what happened is not enough. You need to have a little bit of more information. Where it happened, where it came from, where it's supposed to go to. There's many questions to be asked before we even can begin processing or reacting to what happened, right? So how do we incorporate that information into something that we can receive and say, okay, I know everything and anything about this, now I can act on it, right? And ironically, the analogy is no different than what happens every day in our lives when you receive a letter in the mail, right? So think about that envelope that you receive in the mail. What's on it? Your address, the address of the sender, some other additional information, how much was it paid, how much it was paid for, and so on and so forth, right? So that information enables the system, which is the postal service, to actually deliver it from point A to point B. The mailman doesn't open the actual envelope to look at the payload and to say, oh, it has to go to John or Jane, right? So in other words, there is a structure that defines how to represent an event, right? In Spring and in a lot of other technologies, the structure is called message. But even if you look at sort of technologies that create their own structures, they always tend to be very similar. Like, for example, how many of you are familiar with cloud events? I'll skip that then. But the point I was trying to make is that they have a cloud event abstraction. And guess how many fields it contains? 2. Data and attributes, right? So in other words, it's no different. So whether you call it message, whether you call it something, at the end of the day, you need a structure that helps you to store and store the event and all the information about it. And like I said, in Spring, in my previous life in Spring, I was one of the lead developers of a Spring integration framework. By the way, anybody familiar with that? Good. So then you may heard of me. For us, it's sort of like the enterprise integration patterns, the book cover that you see on the slide was kind of like a Bible for implementing the framework, right? And one of the enterprise integration patterns is message, right? And you can see the message is maybe the simplest structure you can possibly have. It defines the payload, which is an object. It can be anything. And it defines the map, which is headers, which is basically meta information about this particular message, right? So again, could be anything. It's just a bunch of key value pairs. So in other words, just to summarize that event is event, but how do you incorporate, how do you store this event? How do you communicate the event? That's where you need that type of structure. So the messaging to me is a way to incorporate event into something that could be transported and then reacted to or acted upon. So, reacting to events. So process to forward, delegate, right? I highlighted the process because at the end of the day, we process the events, right? So we receive it, we do something, and then we either forward it somewhere else or send a reply back or delegate. But if you think about it and try to understand why I highlighted the process part, because this is where we get into this whole concept of functional versus non-functional requirement. For example, you receive an event and it has some data and you have to do something about this, right? So you need to make a deposit. Like let's say there's a deposit event, right? So you received it, you made a deposit, you updated some database record, and then you have to send a reply, right? Well, the functional part is that what you have to do with that deposit. Send it back a reply, where to send it to, how you want to send it to via messaging or REST or whatever. That's not a functional requirement. So that's the sort of the, don't want to use the word bloat. I'd rather use the word sort of non-functional requirements, basically cross-cutting concern, because if you think about it, you may have tons of different events, you may have tons of different methods to process those events, but they're all going to come from the same source, or they're all going to go to the same or different targets, right? So sending, receiving, that's the non-functional concern. That's a cross-cutting concern, because you can reuse it in many different areas. Oh, by the way, I forgot. So this presentation is structured in such a way that that's why I'm not worried about the time, because once I'm done with the slides, which there's only a few left, then I'll just start coding, and I'll code until somebody kicks me out of stage. So, and also, if anybody has a question, obviously it's a huge auditorium. People in the back don't stand a chance, but people in the front, if you have a question in context, don't wait till the end, raise your arm. I'll try to answer it as we go along, okay? So going back, event processing. So there's simple event processing, streaming event processing, complex event processing. And we can have a whole separate presentation in describing what those different patterns mean and what do they mean to you versus what do they mean to me and so on and so forth. But I just wanted to mention that these are the type of event processing that we have, right? So Spring Cloud Stream. What happened? So this is just a teaser because I have another presentation tomorrow, which, again, talks about event processing and kind of like, okay, well, so we're describing the problem. Where does this problem occur? How does this problem being realized in various different types of systems? So Spring Cloud Stream is one of the frameworks that I also lead, which allows you to bind the event processors effectively to, let's say, sources and targets, right? So at the end of the day, you will end up just writing the functional requirements, and simply by importing something into a POM, all of a sudden it became a message listener or something like that. So it's a little teaser, but if you're interested, come and I'll actually show you a little bit of code today as well at this presentation. But tomorrow I'll speak about this in more details. Again, came from the whole pattern, came from enterprise integration patterns. Basically, we have destinations, we have, the good old pipes and filters, right? That's the fundamental patterns within the enterprise integration patterns. That's the core, right? Because you only have pipes and filters. Pipes represent some type of destination and also represents the separation between the producers and consumers. So producers and consumers are never aware of one another, not even of their existence. They're just aware that they're going to receive from this destination and send to another destination. And then if there's a subscriber, then they're going to process it. If not, then there's a ways to handle what happens in those type of situations. But that's pretty much what that is. So now we're getting into actual Spring Cloud function. So how do we implement event processing? How do we handle event processing? What do we do? How do we do that? Spring Cloud function. So again, I'm not trying to make a statement that the only way to process the events is to use Spring Cloud function framework. That would have been too arrogant of me. But if it was up to me, that's probably the framework that I'd be looking at, and I'll hope to explain you why, and I hope to sort of convince you that that's the right path to take. So here's a quick agenda, why functions and why Spring Cloud function, what is Spring Cloud function, and how do we use Spring Cloud function. So why function? So how many of you are not familiar with supplier, function, and consumer? Very good. So it's the three very simple interfaces that were given to us by Java 8. I wish Java would give us to us since the version 1. Because a lot of our APIs would have been so much simpler. Ask yourself a question. How many times in your life, in your career, have you defined an interface for a service that had a single public method that takes an input and returns an output? And you call it something my service? Probably a lot of times, right? As opposed to, say, something my service implements function. Think about the benefit you would get from that little implements function. I don't know your service. I don't know much about it, but I do know the function. I know the signature, I know the pattern, I know how to deal with that. I know which method to invoke because there's only one. And if I have that knowledge, then imagine how many frameworks, how many assumptions I can make based on that, and how many frameworks I can build that will make your life simpler. And that's what I'm going to show to you in a few minutes. So another interesting rhetorical question that I like to ask when it comes to supplier, function, consumer, because they're simple in a sense that supplier means you're a source of data, no input, output. Function, there's an input, there's an output. Consumer, there's an input, there's no output. Right? Now, knowing that, understanding that, ask yourself this question. I don't expect the answer. What requirement of past, present, or future that cannot be mapped to any one of these interfaces? So, why Spring Cloud function? It's a reasonable question, because if Java gives us function, what am I giving you? Right? Obviously, promotion of looking at your requirements as at least even looking that it will help you. Say, oh, this requirement is a function, or this requirement is a supplier, this requirement is a consumer, because These, not just interfaces, they're patterns that tell me a lot of information. If you tell me, oh, we have a supplier, so you don't have to tell me, a whole paragraph of what it does or how it does, because all I care about the fact that I know it's a source of data. This is where the data is going to originate. Or if it's a consumer, this is where the world will end, right? So, so obviously it's a uniform programming model. That's another thing that Java functions and we sort of this promotion kind of enhances. But what we'll also give you is some additional features that will definitely make your life easier. Because, okay, so you have a function, right? It takes a person as an input. So now you have a byte array coming in the form of a JSON. So shit, I'm going to use the converter, so I'm going to convert it to a person, and then I'm going to invoke this function. Okay, great, but you just complicated your life with a bit of a non-functional requirement, because you have to write a conversion logic, and most likely, if you not properly design your system, you're going to somehow mix it with the functional code, and now your application does become bloated with a mix of functional and non-functional code. And like I said, maybe it's not such a bad thing in some cases, but the point is that later on you're going to repeat or cut and paste this piece of non-functional code somewhere else because I already did it, right? So I'm going to just move it there. And all of a sudden you have this huge amount of duplication and maintenance, because if ever a bug happens somewhere, then all of a sudden you have to change it everywhere. So what we give you instead, we give you, say, listen, this is a non-functional concerns that we can understand. If I can look at the function and I know the signature of the function, I can reflect and extract the type information about this function, which means, and I can do it at the startup time, so it's not like it's going to cause some type of performance issue, right? So we provide you with a transparent type conversion. So we actually, within the framework, we provide type converters, we call them message converters. And the ones that satisfy a majority of the use cases, yet it is one of the extension mechanism, and I hope to show it to you today, depending on the time. But basically, you can define a bean called a message of type message converter. As soon as you define it, then it's going to be added to the stack, so you can define your own, enhance the type conversion mechanism of the framework. Function composition. Again, you'll probably ask me, well, function composition, that's the feature of Java. Function and then function, right? The method and then, or compose. There's two methods, one to the left, one to the right. So, sure, you can. But imagine you have a function string, and you have to compose it with a function that takes integer as a parameter, input parameter. Could you do that? No, you'll get a compile error. But in Spring Cloud Function, you can. Why? Because of the previous point. Because when we compose the function, we still rely on the same mechanism. In fact, I just want to kind of like deviate a little bit from, like I had a recent question because we have a special pipe sign that we use in terms of declaratively composing one function into, well, several functions into one function. And one of the guy in Stack Overflow was asking me, like, how can I handle errors individually within a single function and then I said, listen, this is not a pipeline. I'm not building a pipeline. And it's not a feature of Spring Cloud Function. We just enhance the feature of Java. And the result of the composition is a single function. Right? So in other words, so what I did is I overrode and then method. And within that and then method, I mean, every function is wrapped, and the converters are added, or at least the wrappers made aware of the message converters, so they know, okay, the output coming from here is string, but the input goes in there is integer or person or foo or bar. Then I'm going to dip into the library of message converter and see who can convert A to B. Pojo functions. All right, well, in Spring, we have always been about pojos, right? So that shouldn't be a news to you. So if it acts like a duck, if it quacks like a duck, it must be a duck, right? So if you have a pojo class that has a single public method that takes an input, single output, guess what? We'll recognize it and say, oh, that's a function. Reactive support. So in other words, your function could be foo bar, or could be flux foo, flux bar, or mono foo, mono bar, right? The only difference there is that, again, don't want to spend too much time, is that two functions act completely differently. If you think about it, the imperative function is literally in the event handler, but reactive function is really gets invoked only once, because what it does, it allows you to connect the stream, the flux coming in, let's say, with the flux that you define within the body of your function, and you sending it back out. So it's a runtime function versus initialization function. That's important to understand because a lot of people, like, especially on the Spring Cloud Stream side, asking us like, why can't I apply the same error handling mechanism or whatever on the reactive function? I said, well, think about it. How could you? Because once we initialize and connected your two flux, you might as well throw the framework away because we have no part of your stream anymore. So anyway, I can talk about this also for a long time. Function arity, so function with multiple inputs and outputs, a very rarely used feature, only works on the reactive side. Specifically for reactive use cases like when you have two streams, you want to merge them into one, so on and so forth. Like I said, very rarely used feature, so we're using, you can define up to 8 inputs, up to 8 outputs, and the only reason why 8 is because we use tuples from reactive project reactor, and they have up to tuple 8. So, but think about it this way: if you have a requirement to have like 9 inputs, then maybe you should revisit your requirement. So we just recently added support for bifunction, but I'm going to skip that because it's a very specific use case. We're still trying to figure out what we want to do in general case bifunction. So deployment of package function. I'm going to show you this feature today. So it's ability to not only include function within your code. What if you have a jar library? And what if the jar library is a Spring Boot application, or just Spring application, or not a Spring application, just a pure Java? We have mechanism to say, listen, you can deploy this jar, specify deployment characteristics, and we'll bring it in and identify and recognize your, your function as a function. And of course, integration with serverless platforms. I just mentioned AWS and Azure. There is a Google Cloud function, and there's a few others I can't recall. They're vendor managed. So what did I? Yeah, so all within. So it's all based on Spring Boot, obviously. So now this slide, I was contemplating whether I should include it or not, because. So I decided to include it actually. Why? Because I'm actually going to show it to you in the code. Because while normally when you write Spring Cloud function application, you will never see function catalog. You will never interact with function catalog. You will never see function registry or function registration or anything else, right? Those are sort of the internal feature, but not necessarily. They're only internal features when you're dealing with application that's already integrated using Spring Cloud function. If you are the integrator, then you need to know how to connect your stuff with my stuff, okay? So, so function catalog acts as a function registry, reps function. Remember I mentioned, type conversion, composition, all these other interesting features. So that's where it happens. So in other words, function is a bean within Spring application context. But as a bean, it's as raw as it is, right? It's as if you define the class, right? So when we bring it into the function catalog, we decorate it with all these additional features that allow you to, like I said, composition, type conversion, routing, and many other things, right? So function registration is another important abstraction within Spring Cloud Function, which allows you to do take a different approach. Because think about it this way: you have a bean, and I can read the method signature and say, oh, it takes input as a string, sends output as a foo, right? But what if you had an old legacy function without generics, right? Well, that doesn't make any sense, right? Because functions came after generics. So, but let's say you wrote the code without generics and you have a function, just function, right? So it could take anything, right? But maybe it's a bad code and you don't want to touch it, you don't want to rewrite it, it's sitting in some library. But you want to be able to say, listen, I'm only going to accept input as person, and I'm going to receive output as foo because that's what it expects. So you can actually provide, just like I was explaining about the message, you can actually manually, again, as an integrator, register this function and say the input, basically provide meta information about this function. So now we don't have to do reflective discovery on the function, rather just take your word for it. Again, a little teaser on a Spring Cloud stream. I'm going to get in the habit of doing that. So, but this is kind of describes you what a framework or a system or something that is integrated with Spring Cloud Function looks like. In the middle, obviously you don't see the code, or maybe people in the front do. It's just a simple function, right? There's absolutely nothing there that is Spring related or anything else, well, nothing Spring related, right? There's nothing else that you have to do. But the framework, like I said, Spring Cloud Stream, which I'll talk tomorrow about, will wrap it in a binder and will bind input to a particular destination on, let's say, in this case, in the RabbitMQ, and the output to Kafka. You don't have to do anything. You would have to, and I'll show it to you in a second. The only thing you have to do is just include certain dependency in the POM. So, yeah, so, and there we go. So, done with the slides, and we're going to write some code. Quick question, is these fonts are big enough, or would you like me to make it bigger? Good? All right, if people in the back can see, yell, so I can hear. Okay, so, that's not what I wanted. So what you have right now is I kind of created it this morning using start.spring.io. I'm going to quickly describe. So this is just a very simple Spring Boot application. Obviously, there is Spring in there, but only in terms of Spring Boot application and add beans, right? There's nothing in code that is, aside from the main method, there's nothing in function that tells you, oh, it's going to be Spring thing here all along, right? So, and again, for sake of saving time, trust me, there is no additional configuration or anything else. The only thing I want to show you is the POM file. And the POM file is the obvious Spring Boot starter, and then you have Spring Cloud Function context, and then the boot testing library. These are the three dependencies of this application, right? So now, that itself became a Spring, by defining this particular dependency, this itself, this application became a Spring Cloud Function application because now there's going to be function catalog that I can trigger. So let's write some code. So I'm going to say function catalog. Well, and again, the code I'm showing to you right now, this is not the code of everyday developer. So I'm showing you a little bit of an internals. So put your integrator's hat on. Like, how would you envision integrating your code with Spring Cloud Function if you choose to do so? When it comes to using Spring Cloud Function in frameworks that are already integrated, you would never see that. So now, instead of getting a bean of type uppercase, I'm going to say catalog.lookup, and basically the name of the function is going to be the string value, right? And what I'm going to do here is function. I'm going to skip generics for a very interesting purpose. Okay? So it's a function, right? So this code will work. Trust me. Well, I'm going to keep coding, right? So. And I'm just going to do all right. So I'm going to run it. And also, I'm showing the code, the function code. So uppercase that you can see it, right? So the function code that I'm showing you, you will never see any kind of complexity inside the function because you have to understand, I don't care about the code inside the function. All I care is about the head. Like I care about information about the function, not what's inside. And that I get from the signature. So I'm using my phone not because I'm checking my messages. I have a little cheat sheet in terms of like how I'm going to structure the demo part. All right, so what you've just seen is kind of like how do you interact with function catalog, right? So function catalog is created for you automatically, but nothing is loaded in there. When you do a lookup, so there's a whole logic going on inside of the catalog to say, listen, I'm going to see if this function is already cached, if it's already been wrapped and everything else happened to it, and I'm going to get it from there. But if not, I'm going to go and discover where it is. And obviously, I'm going to go to application context, look at the bean of type uppercase, and then bring it in and say, oh, yeah, that's a function, so let me do this magic, and all of a sudden, it becoming this wrapped function. OK. I'm going to send 23, right? Do you think it will break? Because again, what I mentioned to you before, there is type converters that were added. They're added by default. In other words, they come as part of the framework, and so that took care of it. Well, let's make it a little more complex now, right? So I'm going to add person. I have a class called person here. Again, to save typing, so get name that to uppercase, right? And I'm going to change it to string again, right? So do you think it's going to break? It did. Why it did? Because no converters were found that were capable of converting just a simple string to a complex class called person, right? OK, my person, as you can see, a very simple structure. I can represent it as JSON. So let's try that. Yeah. Yeah. Right. So yeah, I mean, so the question was that it was a class cast exception. So if no converters were found, then it will just attempt to invoke the function anyway, and so on. So there's two reasons for that. First of all, you could have made a mistake with the let's say that whole function registration routine that I told you, where you can manually register it. So you could have made that mistake. So we say, so that's number one. So in other words, the function may still succeed where you it didn't succeed in conversion. Second thing is that is the contract of the message converters, because we have a stack of message converters, right? So we try to be proactive. Say there's methods on message converter. Can you convert? And if it says no, it's not going to convert. But if it says yes, then we give it to convert. But if it doesn't convert, if it returns null, we say, OK, something didn't go right, so we'll attempt another converter and another converter. So in other words, it's very difficult to, we keep talking about this, it's very difficult to go into the proper conversion exception. OK? So for now, it's a class cast, but it never gave us too much problem. But yet, you're absolutely correct, there is definitely room for improvement. Going back to a JSON, so name, do you think this will work? Let's see. It did. And why do you think that worked? Because we live in a world of JSON, and you know, that's reasonable for us to add a basic JSON converter. Yes, of course, you may not like its implementation. You may provide a better implementation. But at least by default, things like this will work. Also, we provide, when it comes to JSON, we provide a little more, because we work both with JSON and JSON, right? So there's a property that you can set which converters are you, which underlying library do you want to use. But again, as a developer who, let's say, as an integrator, with print cloud function, you only have a class called JSON mapper. And it could be either JSON or JSON. So in other words, we have a strategy, but the implementation will come dynamically to you. The methods are the same, so you wouldn't have to care or know. But that's just an interesting feature. OK. Function composition. I'm trying to be cognizant of my time. So let's just get another, let's just start getting some of these beans uncommented, right? So I have a, again, I'm going to change it back to string just to make life a little simpler, because the feature I'm demonstrating has nothing to do with type conversion, right? Well, or it does, so we'll see in a second. So uppercase and reverse, again, very good two functions to demo things, right? So I'm going to go back to a simple string here, right? And instead of looking up uppercase, I'm going to look up this. As you can see, what I did there is I did uppercase. Remember I mentioned the pipe. So uppercase pipe reverse. So what I did is basically declare to the framework that I want to compose this to function. Again, very important to understand, the result of the composition is still a single function. And it uppercased it, and it reversed it. OK, let's complicate the issue. So look what we're doing. Remember I told you about the function composition, that we can compose uncomposable things? Oh, the other thing I did mention is that what about composing function and consumer? Can you compose that in pure Java? Or supplier and the function? Again, you can do that, because composing function and consumer, what is the end result? What is the end result of the function? Supplier, function, or consumer? Yes. So in other words, you can compose function, 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 function. As long as you end with consumer, at the end of the day, it still is a consumer. Or the same thing goes on the other end. If it's a supplier plus function plus function plus function plus function, you're just simply enhancing the business logic, but at the end of the day, it is still supplier. So the left side dictates, or the right side dictates what it is. Anyway, let's run this code. And it gave us class cast exception. So why? Because, again, we're interacting with the simple types. What we need to really do is, oh, no, sorry. I have to go back to, I made things complicated, including for myself, right? And now we got a JSON exception, right? Because now this whole uppercasing everything didn't quite work well with Jackson, right? But it gives you at least a feel for yeah, probably better come up with a better example, but it gives you a feel for the fact that there are type converters that attempted to convert a string to let's just do something so you can see it actually working. Just for fun, to lowercase, right? And then we're going to do uppercase, lowercase, and then reverse, right? Again, it works. So in other words, it is still a person, right? It's still taking a person, but the person is represented as a JSON, so we converted it. So in other words, the previous example of conversion you saw, it was converting at the very beginning of invocation, but now you just saw conversion within the composition itself. So that's, in my opinion, a rather powerful feature. Was there a question? OK. Say it again, please. How to react to this exception? You just, well, this is a typical developer's error that you would have to, you will, huh? So it's a business exception. Within Spring Cloud function, there is no default error handling mechanism. It's a low-level framework. So if you're expecting some type of exception from your functional code, then you use standard, try catch and so on and so forth. Now, if you use it as part of the web framework, there's error handlers. If you use it as part of a Spring Cloud Stream framework, there's error handling strategies. But remember, these are layered approaches, right? So Spring Cloud function is means to an end, right? Not the actual end. So we only provide what we believe is necessary at the layer of Spring Cloud function, but not at the layer of the exception handling is not part of it, because when you're using it as part of a Spring Cloud streaming or web or AWS, you could have various different error handling requirements. So that should be the answer. 7 minutes. Okay. So function routing. So anyway, what I want to do right now is actually skip the function catalog. You basically understood right now that there's a function catalog that you can interact with. But how do you actually use this application in the real world, right? So I'm just going to remove all this code that I've written, right, and leave just one function here for now. And I'm going to do something different here. So what I'm going to do is I'm going to add a couple more dependencies in here. So again, nothing changed, no configuration, right? So I'm going to add a Spring Cloud function web, Spring Boot starter web. Okay. So all I did is just add a couple more dependencies to the POM. So now I am going to start my application context, and I'm going to go to my command line, and I'm going to post to URL localhost 8080/uppercase. And we got ourselves an uppercased function. So all of a sudden, with me just adding two dependencies, so this is kind of like, so throw your integration hat on now the user of Spring Cloud function, right? So you throw as a framework, right? So you just added the dependency, and as you know, Spring Boot dependencies, they're not just a library that define things to a class path. They're more than that, right? So that comes with its own auto configuration. In this case, it's like conventional configuration. So you say, listen, if you add a Spring Cloud function web, then I think you intend to use functions as REST endpoints. So all of a sudden, your function became a REST endpoint. What else could it become, right? So I'm going to add another dependency here. Spring Cloud stream binder rabbit. I'm going to restart it. So I still have the same single function. I can still post to it, but I can do a few other things. So I can go to my RabbitMQ console, and all of a sudden you can see it created the uppercase. It created the uppercase exchanges. I mean, anybody familiar with RabbitMQ? Well, just another messaging system. Take it as such, right? So you just said exchanges and queues, they provide internal routing mechanism, right? So the exchanges are bound to queues and so on. So now I'm going to send a message, hello world. And you can see that connection was created. Obviously, destinations were defined somehow. The message was received by function. And all you did is just added the dependency. And this is where I'm going to kind of go back to what the previous speaker said, that there is, some people were sort of saying like, oh, Spring introduces, there's some complexity in Spring. Well, of course, with sophistication comes a certain level of complexity. So in this particular case, I'm showing simplicity, But think about it this way. You're gonna, if you ask me, what if my RabbitMQ running on a different host or on a different port? What if I need to create certain types of, provide certain types of parameters like user ID, password, all kinds of different things, various different mechanisms to handle errors within Rabbit, how to deal queue and everything else. Yeah, of course, at that point, you will need to provide additional configuration. The same with Spring Cloud Function. If you need to do certain things, you need to provide additional configuration. But until you do that, until you need that, so in other words, it's like convention over configuration. Here it works, and if you need something else, and it's not part of the general accepted convention, then here's how you can add this, but only add what is necessary, not all or nothing. Okay? So, oh, sorry. I, for whatever reason, forgot the name, so I need to look it up. So what I'm going to do here is something different. So I'm going to say function router. Basically, there's another function called function router, and I'm going to try to invoke it. And all of a sudden, we got all kinds of stack traces. So let's see what's going on there. And it says failed to establish routes since neither were provided. And this is again another thing about Spring, and talk about complexities and stuff. We at least attempt as much as we can to incorporate something in our error messages that is meaningful that you can actually act upon. Doesn't always happen, but at least we try. So in this case, well, I'm basically telling you exactly what went wrong and how to fix it. So basically it says neither will provide a Spring Cloud function definition or Spring Cloud function routing expression property. So if well, I don't know how to, Olga, how do you do post headers to HTTP? -H? Just what? Just header? Spring.cloud.function.definition. Because I use usually curl, but Spring Cloud function definition equals uppercase. That's it? Colon where? Instead of equals. All right. Thank you. So, so basically what just happened is that I invoked a routing function. So for example, imagine you have, and this request actually came from the serverless community, like in AWS and stuff. They said, listen, I can define main, because in AWS we allow, again, with Spring Cloud function, basically just added different dependencies, Spring Cloud function, AWS, and all of a sudden your function, the same function, uppercase, became AWS Lambda without you specifically using AWS libraries, right? But what they were complaining about saying is that if I have to expose it via API gateway, then I have to maintain 5, 10, 20 different endpoints. How can I maintain one and provide some kind of instructions to route to this function or that function? And again, it's not just about maintaining endpoints. You have to secure them and so on and so forth, right? So it's much easier to do that. And that's how the routing function came about. So you can do it as simple as say, listen, while I'm invoking a routing function, I provided a definition property. But I can also do, and I'm out of time, unfortunately, routing expression. And you can say, in this case, I'll use simple expression, so I'll do uppercase. Basically, it's a literal expression, so it's the same thing. How do I do literal expression? Anyway, it doesn't really matter. It's just the utility gets in the way. The point here is that you can provide either a definition or expression, and expression could be as dynamic as you want. And before I finish, the reason why I wanted to specifically talk to you about the routing function, because recently we had a CVE, like a really serious vulnerability. Because how many are familiar with Spring Expression Language? Okay, so then you're familiar with standard evaluation context and the simple evaluation context. Well, simple evaluation context give you access to a very limited amount of resources in terms of just your message and everything else, like what's in the class, what's coming in. Where standard evaluation context, you can execute basically any kind of Java code, like runtime, system, runtime.execute, and whatever. So people were able to provide via headers information that could execute code on the client side. So you can imagine how dangerous that was. Basically, your classic code injection. So we had to kind of do all hands on deck and fix it and cut a release. So we fixed it by saying that any kind of expression that comes through message headers will come. And again, even though I provided the HTTP header, again, what Spring Cloud Function does, it incorporates it into the message headers when it receives it. Right? So any expression, any spell expression that comes as part of the header can only work against a simple evaluation context. If it's environmental variable or system property, then you expose to the entire standard evaluation context. And if you don't like expression, there's a callback strategy. It's all well documented and stuff. And I wish I could show you more, guys, but there are documentation, there are test cases, there are a bunch of samples. So just to summarize, Spring Cloud Function is fully Graal VM compatible. We have tons of demos where we demonstrate Spring Cloud Function on AWS in native, and actually had it, wanted to show it to you, but again, running out of time. Thank you so much. Hopefully tomorrow I'll see most of you, if not all of you, at my other presentation. Other than that, enjoy the rest of the conference, and thank you again.